Thanks for coming, everyone. My name is Ingersoll. I'm the CTO of Lucidworks. I'm going to be talking today, kind of a cheeky title, This Ain't Your Parents' Search Engine. First off, just so you know, all those people sitting at the tables in the back, I'm calling on you. All right, this is a big space. It'd be awesome if we could get some people to move up a little bit closer. I get kind of lonely up here on stage, especially with these bright lights. It's good to see people up close. So come on up, otherwise you're getting called on. Very cool. In the interest of time, since I'm between you and me getting to watch Haas be made a fool of up on stage, which is always my favorite event at Lucene Revolution, let's get going. Kind of a funny way to start off a title, Search is Dead. Aren't we at a search conference? Yes, we are. This talk in many ways has come out of trends and ideas and things that I've been noticing in the search space. I'm sure many of you have been noticing in the search space as well. And that little box up at the top, you know, Will talked about this morning during his keynote. In many ways, that search box is dead. Now, of course, you know, what kind of idiot am I? Search really isn't dead. Google still makes, you know, $20 quadrillion as an advertising company off of that little box on a page, right? So what do I mean by that? You know, where is search going? What has it done? What this talk is really about is exploring some of these interesting ideas of things you can do with Lucene and Solr that maybe you haven't thought about in the past. So for instance, pretty traditional classic BI reporting tool, dashboards, all of that kind of stuff. Right, always driven off of JDBC and large joins at query time, you know, et cetera, except for this whole entire dashboard here is powered by queries to Solr. Pretty cool. Another interesting one, you're starting to see more and more people slicing and dicing data in different ways and asking different kinds of questions of that data. This particular one I'm going to show you as a live demo here in a minute is actually doing a number of different kinds, asking a number of different kinds of similarity questions of this data. This is health and medical information, it's drug information, it's molecular information, and we're actually using all of that data, ingesting it into Solr and asking some really interesting questions of it, ranging from the, you know, kind of the traditional faceting all the way down to how do I compare whether two molecules are similar or not. Another really interesting one that David Smiley and Chris Hostetter and a few others in the community have been doing is leveraging Lucene's really powerful spatial capabilities via Solr to start to answer questions about not just spatial questions but time questions, and starting to look at how can I model different kinds of data in a search engine such that, for instance, you can build out charts like this that look at whether people are overlapping on shifts, whether a restaurant is open or not, or other kinds of time-based information. How can you leverage that as part of your scoring capabilities? Last but not least, I mentioned spatial here. Starting to, again, kind of build off of our dashboarding capabilities, using spatial faceting, et cetera, overlaying all of that content on top of maps, et cetera, and really building out all dashboards here that are all really driven off of facets and aggregations and groupings and all kinds of interesting things that our search engine is able to do. And so in many ways, what I'm trying to do here is set forth kind of to get you to think about how you can leverage search in different ways, right? And I think a lot of that comes down to one of the key things I think all of us as search engineers learn as we go is that you need to start to think in fuzzy ways. You start thinking in probabilities, you start thinking in scores as opposed to relational sets and all of those kinds of things. Those are all well and good and we still love them in a lot of ways. But once you start to explore search technology, you can actually answer other kinds of interesting questions. Of course, you know, at the end of the day, you know, kind of what this is all about is that search technology has evolved. If you've been following Lucene and Solr at really low levels, there's a lot of really cool and powerful capabilities in there. In many ways, I'm preaching to the choir at this audience already, but when I go out on the road where people are new to search, some of these things they haven't seen before, and so the idea here is to expose you to that. Naturally, of course, one of the coolest things about search technology in the past few years is that it continues to be really good at what it already does, which is rank things and return keyword-based results. The beauty of it now is that you can scale this up to larger and larger data sets like have never really been attempted in open source search in the past. So don't worry, we're still really good at that keyword matching kind of use case. But we've also expanded to leverage a lot of other interesting things. One of the things I think that you see as a trend in the data world, right, is we all stand up and say, yeah, we live in this polyglot data world, right, where we've got, NoSQL stores and traditional database stores, and we've got Hadoop and all that stuff. But I think everybody who puts forth their data platform wants all of the data to themselves, right? We want to boil the ocean. In many ways, what I think is happening is we are all trying to get at kind of this core question, or this core answer of what does this data mean, right? And so if you look at the Hadoop market, for instance, they're adding search to Hadoop. If you look at the database guys, they've been trying to add search to databases over the years. Well, we haven't just been sitting around in Lucene and Solr, sitting on our hands just doing keyword searches. We've been adding some more traditional database type activities to the search engine, such that you can do things like grouping and joins and aggregations and what I call light relational operations. You can also model much more advanced data types than you've ever been able to do in the past, and many of those are out of the box. What do I mean by light relational? Yeah, if you're going to do SQL and you need full-on SQL capabilities, of course you should still use a SQL engine for those kinds of things. But if your use cases just need kind of simpler joins or certain types of joins, you might find that you're able to do that in Lucene and Solr, and actually it'll allow you to answer kind of other interesting questions as well. Probably the other big some of the other big trends, dynamic faceting, aggregations, analytics, slicing and dicing data as we query it, as opposed to, on the back end having IT build out all of the types of questions that I want to ask of the system and then pushing that out to your end users. Instead, giving them the power to build those things. Another interesting trend I think that's been going on is a lot deeper capabilities around different kinds of data sets. Spatial, probably one of the biggest one. There's some really cool things you can do with spatial around complex polygons, intersections, documents along routes, all of those kinds of things you can model pretty effectively in Lucene and Solr. Record linkage, this notion of kind of as data's coming in, trying to coordinate and bring together or figure out which documents are closely related to answer the question, is this Bob Smith that I saw over here the same Bob Smith that I saw over here? Can I link those two automatically? Can I start to build out the piece of the pie, the puzzle, if you will, such that I can make better decisions about who Bob Smith is or whatever it is my data is. I'll talk a little bit more about that tomorrow in my talk on Solr's future. Last but not least, I think, Splunk and others have brought the kind of alerting mechanism back into vogue. For those of us who have been in search for a long time, document routing, document filtering is nothing new to the search world. But in many ways, people are bringing this and leveraging this at first off of their logs, but then also to a number of different capabilities. And so you're seeing a lot more of that in place where I can, and very quickly in real time, deal with content that's coming in and then ask interesting questions of that data. Last but not least, and I think this really ties it back to my original premise of how we all need to think in a more fuzzy way. If you think about search, what search is doing is it's solving a top-end question or a top-end problem. That is, what search engines are really good at doing is ranking things, and they do that really fast, right? So the traditional use case was go rank a bunch of text based off of what keywords match in an inverted index, right? Well, as soon as you abstract that a little bit and start realizing that you can represent all kinds of different data as tokens, you can then build out custom scoring algorithms, et cetera. You can plug that in a very easy way into Lucene and Solr, such that you can now answer other interesting top-end problems, right? How many people are building out recommendation systems? So there's a few of you in here. Perhaps you know then that there's a number of very large music providers. All of their recommendations are powered off of search. If you've heard LinkedIn talks, the people recommendations is powered off of Lucene. You may have heard Trey Granger here earlier. He talks about how they leverage Solr to do recommendations for people to jobs, etc. In many ways, recommendation, again, search is a recommendation problem. What content should I recommend to this person? But you can also start to represent things like people who clicked on this, clicked on that as a search problem, for instance, or as a top-end problem. For instance, you can do other things like classification as a top-end problem, right? Show me the items, the categories that most closely relate to this query or this item. And so what you have available to you in Solr, I think, is not necessarily going to be the best classifier or recommender on the planet, but it's pretty damn good. Right? And it's often good enough that the savings you get off of the operational simplicity of being able to deploy more Solr makes up for more than the fact of you might be off by a tiny percentage point of accuracy compared to the latest and greatest academic approach to recommendations. And so, especially if you're not a company or a team that has a ton of data scientists working for you, you can start to answer these really interesting questions that your business people are probably demanding you solve without having to go and spend a whole bunch of money. What do? You just go and deploy more Solr. Digging underneath the hood a little bit, I think some of the things that have been interesting around powering this in Lucene and Solr are really almost revolutionary changes in the way the community has built this stuff out. One of my favorites, I think, is that over the past few years, the community has really been focused on reducing memory usage. Obviously, as data is growing, we gotta be able to fill more, keep more data on a single node and in a single index, et cetera. And so, some of the really cool things that have come out of this is leveraging finite state automaton and finite state transducers. To be able to more efficiently represent things like term dictionaries, tokens, et cetera, et cetera. I would encourage you, as you look at how you deal with your strings and your content, to go explore using Lucene's low-level library for those things, even outside of Solr. This is a really awesome package inside of Lucene that is very powerful. I would encourage you to explore that offline. I obviously can't go into too much more details in the interest of time here. Other things that I think have been really helpful, especially if we come back to that top-end problem, is that Lucene and Solr have added a number of capabilities around pluggability of file formats and the way we build our data structures internally and the way we score things, such that if you want to customize how you store content in Lucene, you can do that very easily now. If you've got some fancy statistics that you are doing on your system that nobody else in the whole world does but you, then you can plug that into Lucene in a very well-defined way, take advantage of it in Solr, and have your magic search capabilities such that you can plug in your own similarity scores, et cetera, and answer those harder top-end questions. All of that stuff is so much simpler than it ever was prior to Lucene and Solr 4. Other things that have been going on, seems like a lot of people, they love to think about column-oriented storage, so if you want that, you have the choice. It gets to be really interesting when you look at like the doc value storages in Solr and Lucene. Thinking about, I think at the end of the day, the cool thing about this stuff is you now have lots of different ways of representing your data. So depending on what your access patterns are, your write patterns, your read patterns, et cetera, you can make different trade-offs in Lucene in very flexible ways. I mentioned the spatial capabilities. I won't go into that too much here, but there's a lot of really killer integrations there that are going on. Last but keeping going on there, cursors, people who want to go very deep into their result sets. For a lot of time, if you tried to, if your QA team, for instance, was testing your system, actually by a show of hands, how many people have had their QA people push the very last button on the page, you know, to go all the way to the end of the search results, and you got an out-of-memory exception, and then they weren't very happy with you. Or even worse, you had some customers who did that in production. That stuff has all gotten a lot more stable these days. We've added cursors or deep paging, you may have heard that term thrown around, such that, you know, we're still all about that primary use case of top end, but it's also now possible to very efficiently scale through lots and lots of results, or go through lots and lots of results, such that you can answer and look at data in the aggregate in much more interesting ways. And last but not least, I think, you know, probably the biggest thing, if you haven't heard us talk about Solr Cloud, of course, you know, we're all about making sure that we can scale to large-scale distributed use cases. And then finally, I mentioned some of the database type additions, joins, grouping, pivots. There's lots of new cool things coming in pivot faceting here. I think many of them are actually in already. If you're not, if I'm wrong, ask Chris Hofstetter. He's been leading up this effort for us at Lucidworks, and all that work is going back into Solr and will be available in, I believe, 5.0. The idea here being that you can ask questions like stats and all of that of your pivots at any point in the pivot, so you can essentially slice and dice your data all the way down through a pivot and build out really nice and interesting hierarchical information there. So that's all kind of the high-level conceptual side of this equation. What does all of this mean in practice? Well, I've put together a few demos that I think highlight some of these cases. First one, time series search. I think one of the interesting things, and I'll talk a little bit more about this, is starting to leverage time information in more interesting ways beyond just, you know, kind of the charting information, but also looking at how can you do things like anomaly detection, how can you identify trends on your search data, all of that kind of stuff. So one of the things we did here is build a demo. We took S&P 500 historical data, we took Twitter, we took press releases, mashed that all together into Solr, and went off and built some charting functionality on top of that. If you guys haven't heard, you know, what we've done here at Lucid is port the Kibana project to work on Solr. And let me just, for some reason, not hit the escape button there. So what you have is a blank screen. Awesome. Mirror. 1 second while I hit the mirror button. So what we've built here is, this is all like historical stock chart information, open, close, volume, all of that kind of stuff for, I think I just took like 30 different stock symbols here. You can slice and dice this data. You can look at historical information. You can ask questions of it, like show me all the cases where Apple was trading at above $30 a share. You can go through all of that stuff. If you haven't seen a Kibana banana demo, we're happy to give you a deeper level details here. We can bring in, this is actually using our Lucidworks Fusion here. We ship with Twitter connectors out of the box, so literally just give us your API token, and then you can start indexing tweets. And then of course you can go and build your own social listening platform out of the box here as well. Other cool things you can do this with, obviously, is share your dashboards, etc. So interesting, I think, use cases from the sense of what you're doing here. There's quite a bit of numerical content in here. There's a lot of joining going on, a lot of grouping, aggregations, roll-ups on that content that go well beyond just searching on the basics of that. I would encourage you to download that, try that out. Another one that I think is really interesting is where we take and we start to combine the powers of Hadoop and Spark and things like that to do offline large-scale aggregate analysis of lots and lots of content, and then dump that into Solr, and then use Solr's capability to augment that with more of that fuzzy matching stuff that I alluded to earlier when I was talking about some of the medical use cases here. So this one is a demo of a number of different data sources here. What we've actually done is, if you go to like clinicaltrials.gov, PubChem, Federal Adverse Events Reaction Database, basically all of this information about drugs and their clinical trials and information about, the process of that content, who's searching it, et cetera. The idea of what we wanted to demonstrate was a number of aspects around, how we could leverage Hadoop to do kind of upfront joins of this content and then ask interesting questions of it. And so the idea here is that if I'm an information analyst or a drug researcher and I'm really interested in exploring the space of content around particular areas of research that I'm looking at. So for instance, I might come in here and I might type the word headache. What we do here is actually, what we do first is we go and we've done a join with a list of all the compounds that are federally approved to treat headaches. Okay, and I know it's a little bit small there, but take my word, these are all your standard either prescription or off-the-shelf kind of compounds, things like naproxen, aspirin. Interestingly enough, caffeine is a headache treatment, right? So that's all pretty much straightforward, just search matching. Where it starts to get interesting is actually we've baked in a molecular similarity here that will take those approved compounds and find other compounds that are molecularly similar to that information. Now, why would I want to do that? Well, those ones on the left, they're already approved. Chances are the market's saturated, et cetera. I want to find new and interesting compounds. So how do I encourage that discovery? If I'm a scientist and I want to explore this space, I can start and click my way through this. I can look at the relationships between the chemicals. I can explore all of this. And in fact, every single click I make on this page is a query to Solr underneath the hood, either doing faceting or doing searching or doing other kinds of lookups on Solr, right? And so I can explore things like the chemical hierarchies and all of that. I'm not a chemist, I don't know what that means. But then I can also start to join that with things like clinical trial information. I can see what studies are being done off of the compounds that I've selected in my list there. And we can look at things like who's sponsoring that data, what phases are those studies in, the study types, their status, et cetera. We can also then go and look at the safety information. Remember I said there's that Federal Adverse Events and Reactions database or something like that. Well, that tracks all of the information that people report back to the FDA and back to the government about particular drugs. And so as you slice and dice, you can look at that. This is all driven off of faceting. I think the really cool thing about this is that when people have headaches, one of the really interesting observations they have about adverse events is that headaches, one of the side effects is they have pain. I don't know, you can read into that what you want. I guess pain medication isn't very good at blocking pain. Other things you can do is look at it from an indication level. You can look at it from a location level of where people are reporting this information from. Last but not least, we've added in the NIH reports on funding. This is all using D3. We can drill in on, for instance, the fact in this particular data set, Beth Israel Medical Center got so much money to explore sallia something acid, salsalate and disaliocyclic acid, right? And so as a researcher now, I can have a better understanding of where that content lives, who's exploring it. Should I reach out to those researchers? Are they competitors? And you could imagine that if you started to combine this with your local information, your patent information, et cetera, you can have now a much more complete place where you can explore this data and understand whether it's worth you making an investment or whether somebody's violating your patent or so on and so forth. Switching back, last demo in the interest of time. You've heard a lot about Fusion. I want to just get into that a little bit more here. The basic premise that we built Fusion off of is that signals are what power modern relevance. If you kind of think about the grand scheme of search, on the left, on this side we've got guessing, on this side we've got magic, right? We all know we're never going to get to magic, right? But what you kind of can think about is Lucene and Solr get you somewhere between 50 and 70% of the way there in terms of getting you the right kind of content at the right time. And then really where the rest of that relevance often comes from is, we all just learn from Facebook and Google here, et cetera, is that we want to capture the way users interact with our data and the search system, et cetera, to try to then churn that around into insight. And that's really what we mean by signals powering relevance. A signal is really any little chunk or a bit of information that tells us something about what users care about or what machines care about in that data, right? So it could be a tweet, it could be the fact that we shared an email, the fact that you and I are in this room together, et cetera, et cetera. Those are all signals. Any one signal by itself isn't all that interesting, unless, of course, it's generated by somebody who's really important, right? But when you bring them into the aggregate, it all of a sudden gets a lot more interesting. And we can use those signals to power index time enrichments, query time modifications, result manipulations, et cetera, et cetera. And so with that, this is a little part of the demo is really about introducing Lucidworks Fusion. One of the standard demos I give here is based off of e-commerce. This is where people probably relate the most to this notion of using signals to drive something like recommendations. This particular data set, roughly 1.3 million products, 4 million clicks, and we can then drive and ask interesting questions of that data. So let me switch to my last tab here. Pretty standard. I'm going to show you two different views of this data. The first is a very simple e-commerce front end. You guys are all Lucene and Solr users, pretty standard stuff, range faceting. I've got stats component here. Not so much that this is something I would show to users as an end user of this, but it's interesting to think about from a data quality aspect. I don't know about you, but in this particular data set, I find it kind of interesting that for a commercial e-commerce company, they have items in their index that have a price of 0. Might not be good for business to have stuff for free. It turns out actually they're just like promotional items, but one of the things that you would want to think about, and one of the reasons why I show this here is you can also leverage the search capability to actually make your data better, right? Not just search it, but understand where the gaps are, right? Another interesting one, this particular data set, these guys use what's called the sales rank as part of their scoring factors, right? Well, there's 1.27 million items in here. 1.14 of them are actually missing that value. So if that's an important scoring attribute, it shouldn't be filled in. Again, I don't know what they're trying to do with their data. They may not care about it in that way, so I don't know. But it's kind of interesting to think about how you can leverage Solr to get deeper insight into the quality of your data. We can do other things like hierarchical faceting. This stuff's all built into Solr. Where it starts to get interesting, though, is if we come in here and start doing a query. So I just did a search for iPad. I think if you're like me, you would agree that these results are okay. I'm matching on title, I'm matching on body, I'm doing a little bit of boosting off of that ranked value that's calculated. But I've got the Apple iPad at number 2. I've got some accessories on down the chain. I think, as search people, we all know why these matched. We got the keyword matching. I think one of the reasons, though, that is kind of leaving us a little bit empty inside is that we haven't accounted for what we all know, which is what users care about. The way we do that is actually click this little include recommendations button. What we've done is, you remember all that click data I said we had? It's like 1 month's worth of click data, roughly 4 million signals in our information. We've indexed all of those signals into Solr. Okay, and now at query time, when I hit that include recommendations button, I'm actually querying that in the signals index, say, hey, what's important for this query from a collaborative filtering style approach, not a context and keyword approach. I get back the results of, hey, here's the weights that you should care about for this query, the documents that are most important based off of what people have clicked on in the past. I then feed that back into the core product catalog. We did not touch your product catalog at all. No index was harmed in the making of this experience. And now you have context-based matches, i.e. we got iPad right, but you can also, I think, would agree that the results here are a whole lot better as well because, hey, I'm bringing back what most people care about, and that's even reflected by the sales rank, as you might expect. Just to really drive home how cool this is, I'm going to hit this advanced button, and we're going to scroll down here, and let's pretend that while I'm talking, 10,000 people, if I can type, came in and actually clicked on that Apple iPad 2 with Wi-Fi 32 gigabytes. What I just did there in that flash was index 10,000 raw signals into that Solr index, not the core one, the signals index. And then we can run a little aggregator step that just rolls up all of the differences from the last time we did this. Very quick, very much in real time. Now I can come back in and do my search here again. And at the top, Apple iPad with Wi-Fi 32 gigabytes. Nice parlor trick for a demo. The cool thing here, obviously, is that your clicks are going to be distributed across your result set, usually 1 through 10. We've built in already the math that takes care of things like decay functions over time and all of that stuff. So things that are popular today aren't necessarily going to be popular tomorrow. You have to earn your right to be relevant, as we like to see. The other thing we've done is actually made all of this very pluggable. While we ship with out-of-the-box named aggregations that we think are ready to go and solve your problems today, you can also plug in your own as well and do these kinds of composite rankings and all of that kind of stuff if you wish. Finishing off the demo here, and I know we're almost out of time. Remember I said all of that data was in Solr? Well, what does that mean? We can search it, we can facet on it, we can see it. I can't tell you how many times I go into places where this data, even though you guys are the ones building the system and have access to all the logs, it's owned by marketing. And it's so far away that by the time you get it from Omniture back into your system, you don't even have a clue of what the original data was. Why not just put it all in Solr? And so down here you can see we've got click facets, as you might expect. Most of the content nobody ever clicks on. Some of the content a lot of people click on. More importantly, down the middle here, top queries that are happening in the system, top documents that are being clicked on, that's grouping and joins in Solr. I can pivot through and look at what are the top documents clicked on for the HP touchpad. I can also pivot the other way and say what are the queries that led to this particular item. So for instance, HP touchpad, tablet, touch space pad. Oh, that's an interesting one. 1,300 people searched for iPad and picked the HP touchpad. Now, before you think I'm crazy for HP touchpads, it just turns out there's a real anomaly in this data set is that the touchpad was discontinued that month, and so everybody was selling these things for like $100, right? So all of the data is really skewed, but the cool thing is you can see that right in here, right? And so at the end of the day, what you have now, if you think about it in Lucene and Solr, is the ability to take and have really good context-based recommendations, aka keyword search. You can do collaborative filter styling, style recommendations. And oh, by the way, if you want to bring in the last leg there, the spatial capabilities allow you to restrict and build out really, location-aware content. So when you start to think about combining all of those things together, what you're solving is a top-end problem, and you can do that in spades in Solr. So with that, I thank you for coming. I'm happy to take maybe 1 or 2 questions. Otherwise, before we do that, buses are at the opposite end for Stump the Chump. First one leaves at 4:30, I believe. There are signs. Ask a Lucidworks person if you don't know where it is. And with that, I'm happy to take some questions. Yep. So the PubChem demonstration, the data, the source code for it is not publicly available, but we're happy to share with you what we did there. It's not a product; it's just a demonstration. So we're happy to show you what we did there. Yep. It's a lot of, there's a lot of grunt work on the Hadoop side in terms of joins and all of that kind of stuff, and then we just leverage D3 for the JavaScript visualizations. So happy to talk offline with you on that one.
So I think your Fusion platform is looking really cool, but does it worry you that the people that you're getting the signals from will start to limit the data they're exposing because other products will just mine their data to create a better product from what they offer? Right? You're meshing Twitter data, right?
Right. So the question was, and for those who couldn't hear, was about how, I guess, am I worried about how the market changes in response to any particular application's new insight into the data, right? You know, I mean, I guess, you know, that's the story of time right there, and stock markets and all of that kind of stuff, right? As soon as the market is aware of information, then it automatically devalues that information, and then now we have to kind of find the next big thing. What we're trying to do, I think, with Fusion and the recommendations is, yes, we ship with out-of-the-box aggregations and all of that, but by most stretches of what we've seen in our beta and already with the customers who have adopted is that they have their own ideas about how they want to bring that together. And if that gives you a 6-month advantage or a year advantage, that's pretty significant amount of time in this day and age. So, you know, the other side of it, I think, is you have this real advantage that it's just operationally way simpler to just deploy more solar, right? So it's a great question, though, somewhat philosophical, too. Maybe one more?
Could you expand a little bit on your relevance function? How do you use the clicks and what exactly?
Right, so the question was, how are we using clicks? And by the way, clicks are just an example of signals, right? A tweet could be an example. And in fact, I didn't get into, like, Fusion has all this pipeline capability where you can modify documents as they're coming in. That same pipeline mentality applies to both your main catalog, your main data, as well as all of your clicks. So for instance, you can take our Twitter connector and churn tweets into signals. You don't have to just index tweets, you can churn tweets into signals as well. So every time somebody mentions you, that could be a signal, right? Or every time somebody emails somebody, you want to build out an expert finder for your organization. Maybe you're a huge multinational conglomerate. You want people to know who the Lucene experts are within your company. Those are signals because, you know, perhaps you're looking at email and saying, hey, this person keeps emailing about Lucene. The fact that they've mentioned Lucene a bunch of times might be an indicator that they are an expert. Either that or they're a newbie and they need they need help. So in terms of the math, I don't have the formula handy, but it's essentially the default out of the box one is a time-based decay model where, you know, essentially clicks that are most popular today are not necessarily most popular tomorrow, and so on and so forth. So. Like I said, that's all very pluggable, though. We have, I'll talk a little bit about it tomorrow, but we've added things like co-occurrence-based signals, so now you can do session-based analysis and other kinds of things, such that you can start to look at things like related queries, related documents that are clicked on or shared or interacted with. So. With that, I think, I mean, I'm happy to stay and answer questions, but I don't want to make anybody late here. It's 4 o'clock. Like I said, the buses leave at 4:30. Do not miss Stump the Chump. So thank you very much, and enjoy the rest of the conference.